This is lesson 2.5 out of the Introduction to Algebra book. We are on page 72 for today's notes. Lesson 2.5 is titled Simplifying Algebraic expressions. Simplifying algebraic expressions, otherwise known as combining like terms. And we'll talk about that after we do our warm-up. All right, so warm-up. Warm-up is evaluate each expression when x equals 5. Evaluate each expression when x equals 5. All right, so the first one is 4x plus 7. Number 2, 6x over 10. Number 3, x squared minus 11. And number 4, 5 times x plus 3. All right? In all cases, x has a value of 5. So to evaluate, plug in that value where you see the variable and solve. Okay, our I can statement, what we will be learning in this lesson is I can recognize and combine like terms to simplify, leave an L in there, simplify algebraic expressions. Makes an expression an algebraic expression is that it has variables. Okay, so dark green pencil. Let's get on to the notes portion of our lesson. All right, so I have two note sheets, and I'm going to put them in the usual place here. But on this second one, this good to know one, there's a statement at the bottom about rewriting the expression. Go ahead and feel free to cut that off because we don't use that step as I teach it, and I'll explain why. All right, so as always, you can go ahead and just fast forward through me gluing these in, and I'll pick up in a minute. Vocabulary first. And then a good to know statement here. Okay. Vocabulary. Okay, so we've got some new vocabulary we're going to be talking about in this lesson. We're going to be talking about what is a term, what is a coefficient, what is a constant, and what are like terms. All right? So, a term. A term is a number or a product of a number and a variable. So 3x is a term. 7 is also a term. It's a number. But 7 is a special kind of term called a constant. That is a term with no variable. So if you have a number that does not have a variable, like this 7 here, that is called a constant. All right? This number with a variable is a term, but not a constant because it has a variable. All right? So coefficient. Coefficient is the number that's being multiplied by the variable in the term. So in the case of 3x, 3 is the coefficient. The number that's in front of, that's being multiplied to a variable, is called a coefficient. Right? Like terms are terms that have the same variable. So these two terms here are not like terms because 3x has the variable of x. 7, a constant, doesn't have a variable at all. Right? Now, if I had 3x plus 7x, those two would be like terms, and I would be able to combine them, as I show you in a little bit. Right? But understanding what like terms are simply means do the terms have the same variables? Whether it's one variable or multiple variables, they have to be all the same in order for them to be like terms. All right? So, I want to write a note here also that they don't put into the vocabulary. A variable without, I'm abbreviating W/O, that means without a coef, that means coefficient, has a coefficient of 1. And so what I mean by that is 1x is x. If you have a variable like x here and there's no coefficient in front of it, no visible coefficient in front of it, like a 2 or a 3, or like this 3x here, if you don't see a number in front of the variable, it has a coefficient. Its coefficient is 1. But we don't show it if it's 1. We just leave it off. But it's important to know that when we start doing our combining. So I'm going to draw a little arrow up to this coefficient because I want that note to speak to you about what coefficients are. All right? Now, down here in our good to know, in order to simplify algebraic expressions, you must combine like terms. We talked about what like terms are, and as we do that, it's important to understand that the operation in front of the term, whether it's addition or subtraction, okay, must stay attached to the term. All right? I'll show you what that means in our examples. All right? Okay, so that's our vocab. Let's start looking at what combining like terms looks like. All right, so combine one like term at a time. It's kind of like when we were doing the PEMDAS, and it was one operation at a time. Same thing now when we're combining like terms. Okay, so we're going to combine one like term at a time. All right, so this is how it looks. Let's say we have 4x plus 3x plus 5x, right? I need to combine my like terms and do it one like term at a time. So I'm going to look at my first term, it's 4x, and find out, are there any other like terms in this expression? Well, yes, the very next one has the same variable, 3x, so I know that these are like terms and I can combine them. So 4 plus 3 is 7, and you keep the variable. So now I have taken care of combining those two. I bring down the rest. Okay, and now I evaluate again. Is 7x and 5x, are they like terms? Yes, they are. So 7 plus 5 is 12. keep that variable. And now I have combined those two. I've combined all of my terms, and the expression 4x plus 3x plus 5x is simplified to 12x. And oh look, yay, our pizza is back. All right, so that's how we do it. One at a time, one like term at a time, we combine, bring down the rest. Combine, bring down the rest until we can't combine anymore. Okay? All right, so let's look at a longer one. Let's do this again, but we'll do it with one that's a little longer. All right? So this time I have 9m plus 10p minus 3p minus 2m plus 4m. All right? Okay, let's start with my first term, 9m. Are there any like terms in my expression with 9m? Well, that's a different variable, so no. That's a different variable, so no. Ah, this one has the same variable of m. Remember, the operation stays with this coefficient. So that means I'm going to take 9 and subtract 2 to combine these two like terms. So 9 minus 2 is 7m. And so that, especially when these get long, so that I don't forget which ones I've already combined, I'm now going to cross those two out and then bring down the rest. All right, and then start all over. I have 7m. Do I have any like terms to 7m? Not this one, not this one. Ah, 4m is a like term, and it's got an addition symbol in front of it. So I'm going to add 7 plus 4, and that gives me 11m. Don't drop off that variable, it stays with it. I combined those two, and now I will bring down the rest. All right, so now 11m. Do I have any like terms? 10p, 3p? No, I don't. Nothing more I can do with that. So I'm going to bring it down and then look at my next term. 10p. Does it have any like terms? Yes, right here with 3p, and it has a subtraction symbol with it. So 10 minus 3 is 7. So 7. See, this addition symbol stays with this 10, so that's why it got carried down here. But 10 minus 3 is 7. Don't drop that variable. The p still stays with that 7. All right? So now, those have been combined. I'm done. I carried that one down. Now I evaluate again. Do I have any like terms? 11m plus 7p. M and p are different variables, so those are not like terms. So I have simplified this expression as far as I can. It is fully simplified now. And there you go. There's your answer. All right? Okay, so that's how we combine like terms. Just remember, you keep the operation in front of the coefficient, tells you what to do, and do it one like term at a time. One like term at a time as you move down, and keep your triangle shape. All right? Okay, so notes is just one page on this lesson, and let's go ahead and move on to the practice problems. All right, practice problems for lesson 2.5. We have 5 that you can try and work through. Same instructions for all of them. Simplify each expression by combining the like terms. So we have 1, 2, 3, and 4, and 5 down here at the bottom. All right, let me go back up, and then I give you room to pause and work these out. Pause and work these out. Okay, so let me show you how we simplify these expressions. Number 1, I'm going to start by looking at the first term. The first term here is 5p. Do I have any like terms? That has a variable of y. That's not a like term. Variable of y, not a like term. Ah, there's a p right there. So I would have 5 plus, well, plus what? There's no number in front of that p. But remember, when you don't see a coefficient in front of a variable, what is the coefficient? It is 1. We just don't show it when it's 1. But we have to remember that it is there. Okay? It's kind of like the decimal at the end of a whole number. We don't show it, but we know it's there. All right? So that means then to combine these two terms, I have to add, because that's the operation in front of this variable, I have to add 5 plus 1. Okay? So that gives me 6p. I combined these two, so I'm going to scratch them out so that I remember those are done and bring down the rest. I got 6y minus 2y. All right? Now, 6p. Do I have any more like terms with that? This has a variable of y, this has a variable of y, so no, I don't. So I'm just going to bring that down and look at what else I have. I have plus 6y minus 2y. So that means I'm going to bring down that addition sign that's there and then take 6 minus 2. 6 minus 2 is 4. Keep the variable. Now I'm going to look at it and see, do I have any like terms? 6p plus 4y. P and y are not the same variables, so those are not like terms. I have simplified that as far as I can go. Okay? All right. Number 2. I've got 3x plus 1 plus 5 plus 2x minus 6. So I'm going to look at my first term. Do I have any like terms with 3x? I see right over here is a 2x with an addition sign in front of it. So 3 plus 2 is 5x. I'm going to cross those two out and bring down the rest. Okay? All right, so 5x. Do I have any like terms? No, none of these. These are all constants. They don't have any variables, so they cannot be a like term with 5x. So what's my next step going to be? Well, I'm just going to bring down that 5x. We're done with it. Now I have a constant here of plus 1 and a constant here of plus 5. So that means 1 plus 5 equals 6. Bring down the rest. Okay. 5x, again, I don't have any like terms with that, so I'm just going to copy it down. Oh, I took care of these two. But I have two constants that I can still deal with. 6 minus 6 is 0. So I've got, keep this one, plus 0. All right. Now, 5x and 0 are not like terms, correct? Right. But do I need to show this plus 0? No, I don't, because it doesn't change the 5x in any way. So, I mean, if you left it there, I wouldn't count you wrong, but it's not really the proper way to show it. Our fully simplified expression would be 5x. Okay? All right, let's look at the next two. All right, x plus y plus x plus 2y minus x. Let's remember again, if you don't see a coefficient in front of a variable, the coefficient is 1. So I have x. Do I have any like terms? I see this x right here is a like term. All right, so that's going to be 1 plus, I see the plus sign, 1. All right, so 1 plus 1 is 2x. I've taken care of that one and that one. All right, bring down the rest. All right. Okay, so I still have a 2x here. Are there any like terms to that? Not this y, not this y. Ah, yep, I've got this minus x. So that means 2 minus 1. The 1 is there. We just don't show it. 2 minus 1 means 1. And I'm not going to write 1x, okay? We don't need that. It's just x. 2 minus 1 is 1, and that would mean then 1x. But we don't write it when the coefficient is 1. We just leave it off and assume, all right? So I've taken care of that one and that one. Now bring down the rest. Plus y plus 2y. All right? Are there any more like terms to this x? No, this term is y, this term is y. So I'm just going to bring it down and look at my next one. I have a plus y, so I need to put that addition sign there. There's a 1 in front of that y, plus 2. So I've got 3y. All right? And now I have a term here with a variable of x and a term here with a variable of y. Those are not like terms, so I have simplified this expression as far as I can. All right? Okay, so number 4. 2x. Do I have any like terms here? I have one here and one here, so I'll deal one at a time. 2x minus 1x gives me simply x. 2 minus 1 is 1, and I don't show the 1. Okay? Bring down the rest. Okay. Do I have any more like terms with this x variable? Yes, this 6x right here. All right. So 1, don't forget, it's not 0 plus 6. Okay, there's a 1 there. So 1 plus 6 is 7x. I've taken care of that term and that term. Now I bring down the rest. Okay. Are there any more like terms to this 7x? No. These are both constants and they don't show any variables. So I'm just going to bring down my 7x. There's nothing more I can compare it to, and look to the next term. I have a plus 1, so I'm going to put that addition symbol there, and that means then 1 minus 1, which is 0. Okay? We don't need to show the plus 0, kind of like our number 2, right? So the answer is simply 7x is the simplified form of our original expression. All right? Okay, last one. Last one. All right. So 4g. Do we have any like terms there? Well, this one has a variable of k, so it is not a like term. This one has a variable of g. It is a like term. So I'm going to combine those two. 4 plus 2 is 6g. And I'm going to cross those two off, so I know I've dealt with those. Okay. Now I have 5k. Do I have any like terms to that? That's an H, so no. There's a K, right. And this addition symbol stays with this 5. Okay, so we got to bring it down. 5K plus 1, I don't see it, but it's there. 5 plus 1 is 6K. Leave that there. Take that out, all right? So next one is 8H. Do I have any like terms with that? Yes, this 2H is a like term. There's an addition symbol with the 8, so I bring that down. Then 8 plus 2 is 10. Its variable is h. All right? So now I have a variable of g, I have a variable of k, and a variable of h. Those are all different variables, so these are not like terms. So this is as far as I can simplify this one. All right? Okay, so that's combining like terms. Let's take a look at the worksheet real quick. Worksheet just has a lot of practice at combining like terms, 1 through 12 here. So just use the same steps that I showed you in the notes, and there's probably room to do them if you're writing small right underneath the problems here. Remember to cross out terms that you have already combined so you don't make any mistakes and forget some of them. That can easily happen. All right, and then down here at the bottom of your worksheet, they want you to write an algebraic expression for each word phrase and then simplify it. So you need to put these words into this format and then simplify it just like you did up here at the top. All right? Okay, so that is your worksheet. That leaves you now with the exit ticket. Remember, exit ticket, I don't give you the answers for that. These are extra practice, or your teacher may use it for some other reason. So you can pause here to work these out. Okay. All right, remember, the only way to learn math is to do math, and mistakes are proof that you are learning.